On to number 5, we're still factoring completely. I can see that no number is going to go into 9, 24, and 20 evenly. Okay, my first thought was 3, because 3 goes into 9 and 24, but it won't work for 20. So we've got to just hop right into our box method by multiplying our outside terms. That gives us negative 180 n squared, and we want them to add to be negative 24 n. So I've got to think of all the factors to 180. And if I'm going down that list, the easier way for most people to do that is just to go over into their calculator. Go to y equals and do 180 divided by x and look at the table. Anything that isn't a whole number didn't work. And we can see that there's a lot of stuff that goes into 180. Okay? 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36, 6 and 30, just to give us a start. But of all those pieces, whenever I was looking, the one that stuck out in my mind the most was 6 and 30. Okay? So we had 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36, and 6 and 30. And I'm looking down this list to figure out, hey, what's a pair that can add or subtract to get me to negative 24? Because I'm looking for things that multiply to be 180, which is all of these, and add to be negative 24. Well, if I add these, I get 181. If I subtract them, it's 179. If I add these, I get 92 or 88 if I subtract. 63 or 57, still not hitting 24. Right here we get 49 or 41, so we can tell we're getting closer. If I subtract these, I get 31. If I add them, I get 41, so we're still not there. If I add these, I get 36. But if I subtract them, I get 24. I'm just doing all that quick adding, subtracting in my head. If I subtract them, I get 24. So this is the first one that strikes me as a possibility. So I write them down. Now I play with the signs. I need a negative 24, which means I probably need this one to be negative. Now, if I check it, if I add these together, I get negative 24. If I multiply them together, I get negative 180. So these are my pieces. They're going to go along with these original pieces into my box. We've got 9n squared and negative 20. My two pieces are 6n and negative 30n. Off my first row, I get 3n. Then I get a negative 10. 10 is the greatest number you can pull out of both of those. And because this is negative, it makes that negative. We get 3n here and a positive 2. Okay? 3n and a positive 2. Again, you can check all of this. 3n times 3n, if we were doing our box multiplication, 9n squared. 3n times 2, 6n. 3n times negative 10, negative 30n. And negative 10 and 2 should be negative 20. So there's my answer. 3n minus 10, 3n plus 2. On to number 6. First thing I noticed about number 6 is it's only got two pieces. Okay, so I'm thinking greatest common factor and then possibly perfect squares. Well, if I want a greatest common factor this thing, the only number that pops out to me is going into both of these is 3. Because I know 7 plus 5 is 12, which is divisible by 3. 4 plus 8 is 12, which is divisible by 3. So I don't know what they're going to be, but I know that 3 will go into both of them. 75 divided by 3 is 25, m cubed, n squared. And with 48 divided by 3 should be 16, m n to the 4th power. Now I revisit the numbers just to make sure I got the biggest one. 25 and 16. They're perfect squares, but there's no number that goes into them evenly. So we got to just start by going ahead and pulling out more of our letters. So we're not done with greatest common factor yet. M in both pieces. M there m there, okay? M on both pieces. If I take away the lowest amount of exponents, that means I can take away a 3m. When I do that, I'm going to have 25 m squared n squared plus 16 n to the fourth power. When I do the same thing for the letter n, I get 3m n squared, because squared is the lowest term, just like 1 was the lowest term, or lowest exponent. So what I get is 25m squared plus 16n squared. And now I look at this and I say, oh, wait, crap. This looks like perfect squares, but this is an addition problem, okay? Meaning that we cannot do anything else to this, and that is our final answer.